Now that we've talked about oxygen transport, CO2 transport is going to be pretty easy because it's very similar. So you get the general idea. So carbon dioxide transport in the blood is carried in three forms. Remember that oxygen is carried primarily with hemoglobin and then about 2% dissolved in plasma. CO2 is a little bit different. Okay, CO2 is carried in three forms. Most of it is carried within bicarbonate ions. So remember this formula that we've been showing, that I've been showing you. And if CO2 binds with water, it forms bicarbonate ion. So that's how most of our CO2 is carried in our blood. So once the CO2 gets into the blood, it binds with water and forms bicarbonate ion, and that's how most of the CO2 is in the blood. We also have about 7 to 10% of our CO2 dissolved in plasma, and then another 20 to 30% bound to hemoglobin. However, it's not bound to the heme portion, it's bound to the globin portion. Okay, so let's talk about loading and unloading of CO2. So in a sense, because bicarbonate ions carry CO2, you can see the CO2 is in there. Okay, it loads and unloads similarly to hemoglobin. It's a little less complicated, but a similar idea. So the direction of this equilibrium, according to law of mass action, is going to shift based on what's happening to the reactants on either side of this arrow. So the PCO2 in the tissue, okay, or the muscle, is relatively high. Why is that? Because the muscle is producing CO2, right? So we take, let's see, hopefully this looks familiar. Okay, so when we're doing work, we're taking in food and oxygen and we're producing CO2, right? So the muscle produces CO2, CO2 leaves the muscle, goes into the capillaries in that area, and so in the area of the muscle we see a high PCO2. Okay? If PCO2 is high, in order to re-equilibrate, okay, this reaction is going to shift to the left, okay, to get rid of some of that CO2 to re-equilibrate the reaction, right? And when we look in the lungs, we see that the PCO2 in the lungs is relatively low. Why? Because in the lungs, we're getting rid of CO2. We're exhaling CO2. So what we see in the lungs is that we're losing CO2 to exhale, and therefore the PCO2 is relatively low. This is also going to disrupt this equilibrium, and in order to re-equilibrate, this reaction will shift to the right to replace some of the CO2 that was lost. Okay. So in the lungs, this reaction goes to the left, to the right. All right, 7 to 10% is dissolved in plasma. That's pretty straightforward. And then 20 to 30% of it is bound to the globin portion of hemoglobin. And hemoglobin will load and unload CO2, just like it loads and unloads oxygen. Same basic process. What do you think it does in the tissues? All right, Dingo's not happy with Dexter right now. All right. Okay, so what do you think happens in the tissues? Okay. Hopefully you know, or you guessed, that hemoglobin is going to load CO2 in the tissues because that's where it's being produced, that's where it needs to be picked up, and that's where it needs to be carried to the lungs. And once hemoglobin carrying CO2 gets to the lungs, it's going to unload, which will allow us to exhale and get rid of CO2. Okay? So you should just have a basic understanding of where hemoglobin is loading and unloading oxygen and CO2, why it unloads in one place, why it loads in another place, the factors that affect loading and unloading, the Bohr effect, the temperature, the pH, the PO2, the PCO2, and it's really, same basic concepts over and over again that describe how and why we carry oxygen and CO2 in the blood.